So, der nächste Talk heißt Smart Home, Smart Hacks. Und ich weiß nicht, wie es euch geht. Ich habe immer so ein bisschen Probleme und habe mir noch gar nichts installiert zu Hause, obwohl es mich jedes Mal in den Fingern kribbelt. Ich
haven't installed anything at home yet. It sounds so interesting,
und deswegen habe ich mich sehr gefreut, dass ich diesen Talk heute announcen darf.
And therefore, I'm very pleased to announce this talk
also hier ist Mikhail
because
Steigerbeit
I will know more about the dangers.
Vielen Dank.
Welcome.
Hallo.
Hi.
Heute geht es um die Glühbirne.
Today,
eigentlich nicht
it's
nur um
about
die Glühbirne, sondern es geht
the
um
light bulb.
fast alle Smart Home Geräte, die man sich vorstellen kann,
pretty
weil
much
eigentlich
any
in
smart
fast allen
home
das Gleiche
device that you
drinsteckt.
can think about.
Und warum habe ich mir gerade die Glühbirne
And
ausgesucht? Das
why
ist ganz
did I
einfach. Die
pick
Glühbirne ist
the
so der
light bulb?
einfachste Gegenstand, den man sich
Because it's
vorstellen
the
kann.
most simple device that you can think about. It's a throwaway article.
Alles smart sein und überall muss Internet drin sein und Cloud.
Today, everything has to be smart. It has to be in the cloud. And if you even have that in a light bulb, we can imagine where that leads to. Everybody knows that smartphones can be smart and be dangerous, but what about light bulbs? And that is what I'm going to talk about today. Furthermore, there's quite a bunch of cloud vendors, and what they're doing, I've been looking into a bit, and I've created a proof of concept for various attack scenarios, and I will tell you what consequences that has for users. So in the press, you always read about smart home and the dangers of things that can happen. Even the German regulatory authority, the equivalent of the FCC, is warning about smart Christmas presents, especially devices that contains cameras and microphones, and especially because it's Christmas, and I have a smart light bulb left over, which I will hand out to somebody in the audience. Welcome. My name is Mikhail Steigerbeit. I'm a hard and software developer. I'm mostly working in security research, and I've just created my own startup, the vTrust GmbH. My motivation for this talk is that a customer approached us who wanted to connect his device to the cloud, and we don't know much about cloud, and especially not security aspects of that, and they asked us for help and to help connect it to the cloud. So what you do in that situation, you look for ready-made solutions, something you can pick. And I looked at a number of vendors, and one vendor has brought over 11,000 products to market, over 10,000 vendors in 200 countries, and with over 2 billion requests per day. So a lot of promises by this vendor, rapid development, you can put together a demo in 6 hours, and you can start mass production in just 15 days. And I looked at that, and actually it works quite well to put together something, and you can bring devices online really quickly. And of course I was quite happy to see that they're promising military-grade security. So the first step is to register as a producer or a reseller, and that can happen really quickly in just 5 minutes. And you define a device profile, you use their app, you personalize their OEM app, and you can then quickly upload that to the App Store and the Play Store. It used to be free of charge. Now they want $1,500 for that, but for that amount of money, you cannot write your own custom app. You can also order ready-made modules, even complete devices. So, for example, you can directly order this light bulb, and you just need to apply your own logo and packaging.
Genau. So, jetzt habe ich bei dem Durchklicken in diesem Webformular.
So, when I looked at the registration form, I stumbled across this. So, there's a firmware upgrade, and one of the options were, two of the options were a silent upgrade or a forced upgrade. And how do you actually do an update to the firmware of a light bulb, and what actually happens there? I had already ordered 20 modules to play around with, but they were still shipping from East Asia. And I ordered a couple of light bulbs and smart outlets.
Genau. Dann, wie funktioniert das?
So, how does this work? It's very simple. You register the light bulb with your cell phone. So you put it into configuration mode. The configuration is pushed to the device, and the light bulb connects automatically to the cloud of the vendor, and then you can already turn it off and on again. Because you see Mqtt a lot, quick explanation. Mqtt is a message queuing protocol, a very simple protocol to enable a light bulb to be able controlled from outside your home network. The light bulb connects to the Mqtt broker and can then push information to the broker or can receive information, for example, turning it off and on. So what's actually in there? I opened them up, and almost always I found an ESP8266. Most of them will be familiar with this because it's a very nice microcontroller with wireless LAN and 1 megabyte of flash. And there's a couple of test points on the PCB, and by soldering a couple of wires to that, you can actually update the firmware directly. What's very important? You have to make sure the Far East producers you have to be really careful because the electrical safety of these devices is not always given, and what seems to be ground could be actually connected to the line voltage. So I started looking at the flash, and there's partitioned into two areas, one the system runs from and the other that can be updated. And there's a further configuration section that has the configuration data. And what I noticed was that my SSID and my password were actually there in clear text, not encrypted in any way. That much for military-grade security. So one of the things that you have to keep in mind is that some people use these light bulbs, for example, in their garden shed, and so the neighbor could just unscrew the light bulb and read out these bits of information like the Wi-Fi password. I also found a bunch of keys And that's, for example, the serial number that consists of a prefix, the MAC address of the device, and an authorization key, which proves to the cloud vendor that this is actually one of their modules. Then there's a product ID, and this product ID is created when you register your line of devices in the cloud. And this product ID is generated, and then the product vendor actually programs that into the devices you order from them. And there's additional keys. These are used for encrypting the communication. So I only had devices from some other vendor. So the question was, how can I look at that? And so I simply tried to put my own product ID into the flash at the right point in the flash and correct the checksum to make it a valid firmware file, and flashing that back into the store-bought light bulb, and immediately my device showed up in my cloud account.
So viel zum Thema Military Grade Security. Aber mich hat sehr verwundert, warum
what I found extremely confusing is why I was wondering why I saw the email address I used to register the device. And when I went to see the detail information, I saw a lot more information. Like, for example, the serial number, or the cell phone number if you use the cell phone number to register the app, and there's the geolocation, the coordinates. Now, I don't quite know why the manufacturer or the reseller of my light bulb should know where it's being used, but probably there's a reason for that.
Ja, die Anschalt- und Ausschaltvorgänge weiß auch jeder, wann wer zu Hause ist.
The manufacturer can tell when a bulb is turned off and on again. Usually, you only get 7 days, but if you want more, you just have to ask for it.
Ja, dann gibt es noch schöne Auswertungen, wo man sieht,
there's also nice logs and statistics where you see how many people turned on which devices, so that you can use the market more efficiently.
Für mich war das ein bisschen komisch, und meine Kundenanfrage
war a bit weird, and my custom request was a bit related to how I can protect customer data, because I have no idea who is able to access that data. So I sent a query to the company asking them whether it's possible to use the devices without sending data to the cloud, because for my customers it might not be a great idea to push that data to the cloud. The answer from the manufacturer was no. It's not possible to use these IoT devices without storing the data in the cloud. But they told me they protect the data very well.
Und was sie auch noch gemacht haben in diesem Kontext, weil sie haben mir direkt noch ein Dokument mitgeschickt.
What they also did in this context, they sent me a document telling me how I can better use these customer data for myself.
Vom Prinzip ist es so, dass in den Apps immer
In principle, in the apps, there's data protection guidance that is very long and might be confusing. And if I were to talk about this during this talk, I would need half an hour or more. So I'm not going to go into detail here.
Das Bundesministerium für Sicherheit hat einen Lagebericht zur IT-Sicherheit.
The German Ministry for Security, the BSI, has published a situation report in 2018. Splitting this into several different areas of threat. Firstly, the area where the user is the direct or indirect target of damage himself, with the possibilities to manipulate devices or to read data from them. the second area of threat is the possibility for others to be harmed through, for example, something like a botnet being built, crypto mining being done, or identities being hidden through IoT devices. Now, all of these possibilities the BSI mentioned can be achieved with these devices. Crypto mining is a bit difficult because the computation power is low, but in theory it would work. So I thought about what would be a possible attack scenario for such a light bulb, and in general it's the case that the light bulb as part of the network can access anything else on that network, like for example holiday pictures or anything else using ARP spoofing or something similar. And after accessing this data, I could send it to a server in the outside world. So what I did was, first I sent my access data, my Wi-Fi protection key to the outside world, and that worked very easily. So, quick summary. Anyone can very quickly become a manufacturer or reseller of such IoT devices and automatically connect all of these devices into your own cloud. And both the manufacturer and the supplier of that manufacturer can access the data, seize the firmware, can change the firmware, and worst of all, can access all of the related user data. And an extreme amount of data is processed and created, including geolocation and everything. Secondly, I've been told the creation and collection of data cannot be turned off, which is an important point. So as a German manufacturer of such devices, it's impossible to legally use them. Additionally, it's very simple to build such devices. It's also possible to buy them and send them back in returns. It's even possible to get one gifted if you're attending a talk like this. It's very simple to bring them into circulation.
So, jetzt war eigentlich für mich die Arbeit beendet, weil meinem Kunden konnte ich natürlich nicht mehr helfen.
That kind of ended my work, because at this point I was unable to help my client, because we could not use a Chinese military-grade security vendor. It had to do it ourselves. So the question was, can we run such devices without the connection to the cloud? And secondly, of course, I really wanted to have the proof of concept of the Trojan IoT device. So I went into the second round. In order to do that, I built a test device, a Raspberry Pi running Kali Linux with a software access point. I needed my own DNS server to reroute queries, had an own HTTP server, an MQTT broker, and used Wireshark to analyze and used BetterCap to manage the middle connections. So firstly, I looked at the data, what flows into and out of the device. It's very simple. There's three things. There's DNS request, there's HTTP requests, which are usually unencrypted, including requests that may contain important data like keys. And finally, there's MQTT that is usually encrypted. But even if the light bulb itself implements HTTP and MQTT, it's usually not even used. Again, you don't see it here on the slides, but again, this is very secure. Even the local key is available in clear. I then ran a small crypt analysis to figure out what was in the encrypted data, and because the ESP processor is being used and that has an extensor core, disassembling the binary is very difficult because there are no good plugins or disassemblers for this extensor core. So I looked into this cloud provider who provided a very good API documentation that also tells you a lot of the details. It has a lot of errors though. And there's also an SDK, which I requested, but before I received a copy, I found one on the internet that contained some pre-compiled libraries that I could use, that I could analyze and investigate to get more insight into the libraries.
So I created a quick 60-line script, and it's a very simple AES 128 encryption and MD5 over certain data parts, and they're signed with an MD5. Not quite military grade. Then I looked at how the registration actually works. So the mobile app requests token from the cloud, sends it to the lamp with a kind of a special protocol named smart config, and the light then asks over HTTP for, or sends the token and asks for the MQTT details. Then a second HTTP request is sent again with the token asking for activation, and that returns the key material that is then used to establish a secure MQTT connection. What I was more interested in was how the upgrade works. So, because I wanted to add my own firmware or create my own firmware. So, the update works. You start on your cell phone, and that the trigger requests from MQTT, and that is transmitted to the light, and then the light asks for the actual update location, and then it downloads that binary and installs it into the currently unused partition. So for me, it was very simple. I created my own MQTT server and tried to create the trigger myself. And with a man-in-the-middle attack, I modified the HTTP request and sent the desired firmware from my own HTTP server. So I set up my own MQTT server, and the only thing I needed to do was to change the DNS configuration so that for the DNS address, it would connect to my own MQTT server instead of the one in the cloud. And we can see here how messages are exchanged. And the next step was the hardest to actually implement to understand the upgrade trigger. This is actually encrypted, and apparently the protocol number 15 is the update trigger, and by generating the trigger with a specific message, the timestamp that is used is actually not checked very well. It's not very exact. And So by sending that with the Mqtt command line client, I could actually trigger the upgrade, and I wrote this little script to automate all that so I don't have to type in many commands on the command line. I will publish this code after this talk, so you don't have to do this by hand.
The next
step was to redirect the upgrade request, and with Bettercap you can change HTTP requests in real time. And since I was using Kali Linux as my own access point, I could easily put Bettercap into the data stream and simply make it rewrite the HTTP request. So with a bunch of scripts,
dass irgendwelche fertigen Strings in den Replies sucht und dann einfach ersetzt.
You write a script that searches for certain strings in the request and in the reply, and that you can then replace them on the fly, and then you see how the requests are changed, and the firmware is requested from my own server. So then we come to the actual firmware. So I wanted to create a couple different versions. So one of them was just to push out the Wi-Fi password, and then I wanted to create my own completely new firmware.
Ganz oben der ersten Zeile sehen wir den access point.
So we see here the access point software, then the Mqtt server, then an HTTP server for the firmware binary, a Python 3 script that decodes all the commands, the Bettercap that updates the requests, and here we see a terminal that shows us the output from the firmware, and as we start that, and with the final command down there, I'm sending the trigger request, and then we can see here comes the request. And now we see in all the windows the requests being sent and processed, and then we have the new firmware installed and it's running.
So, jetzt ging's die Firmware, die drauf geht.
So the firmware that I wanted to create was a proof of concept as a Trojan. So the Trojan is connecting to its own server somewhere on the internet, sends the Wi-Fi credentials, and creates a reverse tunnel, so I can get back into the local network. In this case, it's acting as an HTTP and SOCKS proxy, so you can use any browser. You configure the IP address of my server, and you can look into the network of the light is connected to. And it was important to me that this is fully transparent. The user of the light should never notice that something is astray, and the light continues to work as normal. So on the left-hand side, we have a terminal showing the serial output from the light, another Python script that runs the proxy, and somewhere in the below window, we see somewhere on the internet. Here, the light connects to my server, and now I can create the external ID of the light, and here I'm adding the proxy, and now we can see that the request actually reaches the light.
Then
I wanted to access something on the internal network, So I'm accessing fritz.box. So I can see that a Fritzbox router is running on the local network. So with the proxy, you can not only use the internet account of the victim, but you can roam around on the local network.
Die große Frage ist, warum ist es so gefährlich?
The big question is, why is this so dangerous?
Man weiß nie, was in so einem Gerät drinsteckt. Und
the answer is, you never quite know what's inside such a device. I was really discomforted by seeing the option of a silent upgrade in the manufacturer menu online. There's no confirmation in the lamp from the user required to update the lamp, and so it's possible to just flash any sort of Trojan into a lamp that you control. So if you sold 20,000 lamps, it's possible by just clicking through your web interface and uploading a Trojanized binary with the new firmware to update all of these 20,000 lamps without the user noticing. And as I said, the way I did it was by soldering the lamp and then flashing. But for the cloud provider, it's a bit simpler. They can just do that using their own tools. Another topic for me was, can I run this without a cloud? Now, if I have such a lamp at home, then I thought there's different open source options that have great functionality and can do even more. And the normal workflow of flashing such a lamp is to break it open and to solder the contacts, and that is beyond what most people are willing to do. But with the method I showed in the demo, we can also flash another firmware into the lamp to run it without a cloud. And I'll publish this so that everyone can use it as they see fit. Summarizing, the security level of such devices is minimal. Everything I tried directly worked. There was no encryption of data that was stored in the device itself. Neither the firmware nor the updates were signed, so I could directly install things, and the stored data isn't encrypted. And in the most critical of cases, data transmission was also unencrypted. In some cases where transmission was encrypted, it was not much of a hurdle. What I found even more disconcerting, though, is the collection of data. It's incredible to me that both the cloud provider and the manufacturer needs to have all of that data that is stored. There's no reason for any of these participants to have the specific location of the light bulb that I was able to track down to the desk that I had the lamp on. And it's disconcerting to see who might have access to such data. It's also very unclear where that data is being sent. In some cases it's said that that data is stored only in Germany, but it might be sent to the Far East, and who really has access to all of that, no one knows. So yes, the big problem for me is that this affects the most simple of consumer goods. A light bulb is there to bring a bit of light and is about as simple as toilet paper. And bit by bit, everything is becoming smart. And even if devices that are as normal as a light bulb, and if such devices have to be smart now, most people will not realize the security risks associated with installing such devices. They'll see the user effect of being able to turn off and on the lights, but what they don't realize is that might compromise the local network and might allow access to personal and private data inside of that network from the outside. The positive that I take from this is it's possible to easily turn off the manufacturer cloud. That also shows that it's not necessary to have that cloud connected, because it's possible to use it after removing all of the cloud features in an even better way than before. And my call to vendors and manufacturers would be to improve on that and allow the ability to run such devices without the cloud connectivity. And to have clear answers to questions if someone asks if it's possible to not store that data.
Ich habe schon angekündigt, ich werde noch weitere Infos.
As I said, I am going to upload some more data on our website for download, including the scripts to flash other firmwares onto such devices. I haven't been able to finish that yet, but it will be online soon.
Jetzt sind wir beim Fragenteil angekommen.
With that, we've arrived at the Q&A, and I think someone is coming onto the stage to manage that. Thank you very much, Michael.
Ich bin immer noch beunruhigt und fühle mich überhaupt nicht military grade.
Disconcerted. I don't feel military grade anything. Question to the young person who received the light bulb. Do you want to keep it? And he nods.
Okay, gut. Haben wir denn Fragen? Geht schon los.
Do we have questions from the audience?
Mqtt 2, bitte.
Ja.
Ist MQTT jetzt verschlüsselt oder nicht? Ich habe es nicht ganz verstanden.
I haven't quite understood. Is MQTT encrypted or not?
In diesem Fall ist es mit AES verschlüsselt. Sorry, it is encrypted with AES in this case.
Wir machen gleich bei dir weiter. Er kommt dann als Nächster. Deine Frage bitte.
Lösen die alternativen Firmwares, die du vorgestellt hast, das Problem von dem Klartext?
The other firmwares that you mentioned, do they solve the problem of storing the password in clear text?
I haven't looked at that in detail, but since it's open source, you can research that yourself. You have full control over that, and you can. I haven't checked how that works in detail.
Okay, vielen Dank. So, nächste Frage. Mikro 1, bitte.
Wenn die Lampen so populär sind,
if those lamps are so popular, would it not be possible to have a foundation that sells 10 million lamps on which we can run 10 million Tor exit nodes?
Also das ist natürlich eine sehr interessante Idee.
That's a very interesting idea, and I think you can do much more with that. Theoretically, you just create a catalog of different firmwares, and we add things like that, and then we could run it like that. But the CPU power of these devices is very limited.
Okay. Ich denke mal, wir nehmen jetzt die nächste Frage. Mikro
Thinking
1
we'll take the next question from mic number 1.
Du hattest am Anfang des Vortrags gesagt, es ist ein sehr bekannter und namhafter Hersteller.
Talk, you said it's a very well-known cloud vendor.
Kannst du uns vielleicht ein bisschen mehr dazu sagen, welche Produkte der Hersteller herstellt und
verkauft, a little bit more about what kind of product this vendor sells?
There's pretty much everything, and it's not only one vendor. There's 10,000 of different vendors, and they all use this technology, and they're all over the world. There's German ones, and you think you're buying a German product, but in reality you have this OEM product in it. And there's everything like kitchen devices, fridges, 30 different categories. It's pretty much in everything. The light bulb was the most simple for me, and the switchable outlets.
Okay. Ich würde jetzt gerne mit Mikro Nummer 3 weitermachen. Da stehen nämlich auch schon 2 Leute. Ihre Frage bitte.
Ja, die Frage ist, ob du auch die Shellys angeguckt hast. Die haben ja diese Jumper-Kabel-Ansteckmöglichkeit, aber die haben auch die Cloud ausgeschaltet. Weißt du da was zu?
Did you look at the Shellys?
Weiß ich nicht, aber
no, I didn't look at that. I'm not sure if they use this cloud out of the box. I think it's an open source hardware,
nicht von dem Anbieter selbst läuft.
But not by this vendor.
Okay, danke. Dann nehmen wir das nächste Mikro, Nummer 2, bitte.
Ja, ich bin kein Programmierer.
I'm not a programmer, but that doesn't improve my nights.
Welchen Tipp gibst du? Nicht im Fernen Osten kaufen, nur Markenware?
My question to you is, how should we best buy such things?
It's really hard to make a recommendation because you never know what's in there. And there's German companies that produce that use these devices, and I haven't looked at the competition. But it's for me, the thing really is to use your own firmware. So there's a small company somewhere in the Far East. They create one company after the other after different names. And if you go for name brands, then it might be different. So that might be different.
I see a light that tells me the internet has a question. And the question from the internet is, what alternatives are there to storing the Wi-Fi password in clear text?
Well, in reality, you can always find out. But it doesn't have to be this obvious. And if you just dump the ROM and you can have the key in clear text, it's so easy. You can just scroll through the hex dump and you see it. Just XORing the data would have obfuscated it a bit and it wouldn't have been quite as obvious.
Ich nehme erstmal das Mikro Nummer 7, da wartet schon jemand länger. Die Frage bitte.
Ja, das ist jetzt fast eher eine Anmerkung.
Es tut mir leid, wir nehmen leider keine Anmerkungen. Wenn du eine Frage hast, dann melde dich bitte mit einer Frage. Kommentare möchten wir bitte nicht. Dankeschön. Dann
okay, we're not taking comments, but just questions, please.
Ja, hallo.
Hi.
Der MQTT-Request, der geht ja direkt an den Cloud-Hersteller,
so
oder?
So this MQTT request goes direct to the vendor, right?
Yeah, right. MQTT is basically the protocol to get from the internet into the local network, and that's kind of a tunnel. And a topic is subscribed to by the light, and another topic is used for the light to publish status updates.
Wir haben noch eine Frage auf der 5, die wartet schon länger. Bitte schön.
Danke sehr. Gibt es irgendwelche Einschränkungen, wenn ich ein Internet of Things WLAN aufbaue mit sehr eingeschränktem Internetzugang?
Create a separate Internet of Things Wi-Fi that is restricted.
It is possible with the firmware that is on the devices with just a local network. but the light is actually open on port 6668, and you can control the light locally by just connecting to that port. And you need to use the local key to send data, but you can still use the light even when the light has no internet connectivity.
Ich würde sagen, 3 Fragen machen wir noch?
Let's do 3 more. Mic number 1, please.
Hast du dir angeschaut, wie die Sicherheit auf der Serverseite
von diesem Cloud-Anbieter ist? At how the server-side security on the cloud vendor's part is, whether it's possible to read data from other manufacturers or the MQTT topics.
I've tried sending an MQTT message to a different device, but I have not looked at that in detail, and I have not tried to capture any accounts or anything else.
Okay. Wir haben da noch ein bisschen Zeit, deswegen, wir machen noch ein paar Fragen mehr, wenn dir das recht ist, Michael.
Ja, klar.
Okay, dann würde ich jetzt den Signalengel nochmal einleuchten lassen.
Bitte, Frage, was wären in
Question
der Praxis
from the internet.
Best Practices für IoT-Devices?
In practice, what would be the best practice to do updates with IoT devices, whether not to run or not to run them?
That's really a hard question. It's hard to realize
von der App kommt und die dann
sometimes
so ist, dass der User definitiv
when the update comes through the app and how the user controls that, it's really hard. It's really dependent on the implementation.
Okay. Ich glaube, Mikro 7 ist noch jemand.
Mic 7,
Deine
please.
Frage bitte.
Das war die gleiche Frage.
Ja, okay.
It would have been the same question.
Okay, dann Mikro 8.
All right. Mic 8, please.
Da hat jemand aufgegeben. Okay, es blinkt noch. Habe ich das richtig gesehen?
The light is blinking.
Ah, okay, die 3. Bitte
Okay,
schön,
number 3.
Thank you. So this clear text local key over HTTP, how often is it sent? Only the first time, or does it send it more often?
This is
Der Klartext-Request über HTTP, wie oft wird der gesendet? Nur das erste Mal oder mehrmals?
I mean, HTTP in general is not encrypted when the cloud sends something to the bulb. But the keys are only transmitted during activation.
Thank you.
Okay, vielen Dank. Wir haben da noch ein Licht. Deine Frage bitte. Ja, Signal Angel, genau.
Question from the Signal Angel.
Ist der Sprecher bereits einen sicheren IoT-Gegenstand begegnet?
To the speaker, has he ever encountered a secure IoT device?
Maybe, but not that I'm aware.
Mikro 3, bitte schön.
Mic number 3, please.
Gibt es Anzeichen, dass die Daten der User verkauft werden?
Are there signs that the user data is being sold? And if no, how easy would it be to figure that out? Some time ago there was a talk here called Build Your Own NSA, where a company was selling user data. That could be possible.
Anything I could say would be speculation, but it's remarkable how much money is behind these companies and how many devices they're selling. So it looks like it's more money than you could actually earn with these kinds of devices. That would be a great idea for a new talk.
Eine Frage haben wir von der 7, bitte schön.
Question at Mic 7.
Bin ich richtig in der Annahme, dass Zigbee-Geräte nicht betroffen sind?
Am I right in assuming that SIG devices are not affected?
That really depends on whether the Zigbee gateway is connected to the internet, and if the bridge is using this technology or something similar, then it's basically the very same thing. So it wouldn't be the light, but it would be the bridge that would offer the attacks.
Ich hätte eine kleine Frage zu dem Smart Config.
I have a question regarding smart config. With the smart config, the device, the config is being sent over the Wi-Fi SSID. How difficult would it be in, say, in a big building to simulate something like that to all devices?
You don't have to simulate this because the protocol is fully open. It's very simple to listen to the activation processes, so you can very easily grab the Wi-Fi access details from those messages.
Eine Frage aus dem Internet, bitte noch die Frage stellen, Signal.
Entschuldigung, nein, keine weitere Frage aus dem Internet.
No more questions from the Internet.
Wir haben auf der 1 noch eine Frage
so,
und dann.
We'll take one final question from Mike 1. Go.
Es wurde ja gesagt, dass es auch deutsche Anbieter gibt, die diesen Service nutzen.
You mentioned that some German manufacturers also use that service. Do you think that is legal according to GDPR and deletion of data?
I can't really answer that. My colleague has looked into that a bit more.
Sachen analysiert habe. Und, vielleicht kriege ich ihn ja noch dazu ermutigt,
maybe I can convince him that he is going to give a talk about that.
Sehr lange und sehr viel drüber sprechen.
I think you can talk about that a lot and in depth because the legal framework is quite complicated.
It sounds like an interesting follow-up. Okay.
Das ist dein Applaus.
This is your applause.